Okay, I'm just picking some that I had laying around, some books. I'm just gonna read. Um, However, I did have some information that I wanted to read. I guess first I'm gonna start with um, let's read some about Scotland Yard first. Scotland Yard has some information that I seen that was interesting. And I may have read some stuff about it a while back off Wikipedia. Scotland Yard. I'm not the best reader, so I'm practicing. Um, Scotland Yard, um, New Scotland Yard is a meton- metonymous for the headquarters of the Metropolitan Police Service (MPS), the territorial police force um, responsible for policies most of London. The name derived from the location of the original Metropolitan Police headquarters at 4 Whitehall Place, which heads real a a rear entry, a street called Great Scotland Yard. The Scotland Yard entry became the public entry to the police station, and over time, the street and Metropolitan Police became synonymous. The New York Times writes in 1964 that it's just a Wall Street gave its name to New York financial district. Scotland Yard became the name for policy activities in London. Excuse me. The force moves from Great Scotland Yard in 1990 to a newer complex building in the Vecchio embankment, and the new Scotland Yard was adopted for the new headquarters. And adjacent buildings were complex in 1990. A third building was added in 1940. In 1967, the MPS moved its headquarters from the third building complex to a tall, new construction building on Broadway in Vecura. In Summers 2013, it was announced that the force would move the Curtis Green building with its third building of New Scotland Yard, previously cited 1890 to 1967, and the headquarters would be renamed Scotland Yard. In November 2016, MPS moved its new headquarters, which continues to bear the name of Scotland Yard. Scotland Yard Buildings is now owned by India billionaire Yasuf Allen M.A., chairman of Lula Group International. The Metropolitan Police Service is responsible for laws enforcement within Greater London, exclusive, excluding the square mile of the city of London, which is convert, 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 convert by the City of London Police. Additionally, the London Underground and National Rail new networks are the responsibility of the British Transportation. The Metropolitan Police was formed by Robert Peel with the implementations of the Metropolitan Police Act, passed by Parliament in 1829. Peel, with the help of Eugene Francis Vidoqua, selected the original site on Whitehall Place from the new police headquarters. The first two commissioners, Charles Rowan and Richard Mayne, allowed, along with various police officers and staff, incorporated the building previously a private house for White House Place, backing into a street called Great Scotland Yard. By 1878, by 1879, the Metropolitan Police Headquarters had expanded from 4 Whitehall Place into several neighborhoods address, including 3521 and 22 Whitehall Place, 8 and 9 Great Scotland Yard, and several stables. Eventually, the service outgrew its original sites, and new headquarters were built on the Vectoral Embank outlook the River Thames, south of what is now the Mystery Ministers of Defense headquartered in 1888. During the construction of the new building, works discovered the dismantled torso of a female. The case, known as Whitehall's Mystery, was never solved. In 1890, police headquarters moved the headquarters to the new location, which was named New Scotland Yard. By this time, the Metropolitan Police had grew from its initial 1,000 officers to about 1,300 and needed more administrative staff and a bigger headquarters. Further increase in the size and responsibility of the force required even more administrations and space. Therefore, new buildings were constructed and completed in 1906 and 1940. so that New Scotland Yard became a three-building complex. The first buildings are now a grade one list structure known as the Norman Shaw Building. The original building at Whitehall Place still has a rear entry on Great Scotland Yard. Stables for some of the mounted branch are still located at 7th Great Scotland Yard across the street from the first headquarters. By 1960, the requirements of modern technology future increasing in the size of the former meet uh, meant that it had outgrew its three-building complex in vectoral embankments in 1967. New Scotland Yard moves to a newer complex building on Broadway, which was an extended office block acquired under a long-term lease. From 1967 to 2016, the third building, then known as the Curtis Green Building of the first Scotland Yard, was partly used as the base for the Met Territorial Support Group. The Met senior management teams who oversee the services were based at New Scotland Yard at 10 Broadway, close to Street James Park Station, along with the Met's criminal database. This use this use a national computer system developed for major crimes required by all British forces called Home Officer Large Major Inquiry Systems. More complex, more commonly referred to by the Backronium homeless, which recognized the great financial detective Sherlock Holmes. The training program is called Elementary after Sherlock Holmes, well known yet appropriate for phase elementary, my dear Watson. Administrative functions are based at the Empress State Building, and communication handling at the 3 Metcalfe complex rather than at Scotland Yard. During the 2000s, a number of security measures were added to ex, extraordinary external of a new Scotland Yard, including concerns um, barriers in front of ground level windows as con, uh, a countermeasure against car bombs, a wall around the entry to the building, and a um, convert walkway from the street to the entry into the building. Army officers from the the mop Dipop Dipopmatic dem, 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 project, protection group, diplomat protection group. There we go. Diplomat protection group parole the external of the building around with security staff. In 2008, the Metropolitan Police Arthur brought the free whole of the building for around 120 euros. In May of 2013, Metropolitan Police Commission confirmed that the new Scotland Yard building on Broadway would be sold, and the force headquarters would be moved back to the Curtis Green building on the Vectoral Embankment, which would be renamed Scotland Yard. A complexion, a compet, a, com, a competi- competition, a compet, a competition was announced for architects to redesign the building prior to metro prior to the Metropolitan Police moving to it in 2015. This building housed a territory policing headquarters and is adjusted to the original New Scotland Yard Norway Shaw North building. In December 2015, construction work on the external of the Curtis Green building was complete on October the 31st, 2016. The Metropolitan Police staff left New Scotland Yard with when new ownership of the building was passed to Abba Dahaba Financial Group and moved to the new headquarters. The new Scotland Yard building was to have been opened by Queen Elizabeth II on March the 23rd, 2017, but the same day it was announced that the royal opening would be postponed due to the processing preceding day territory attack at Westminster Man, 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 Minister. The Black Museum, also known as the Crime Museum of Scotland Yard, found in 1873, is a collection of criminal memorabilia kept at New Scotland Yard. See, as a kid, I always had this love for Sherlock Holmes and Scotland Yard. I thought he was just so cool. Like when the movie came out, Sherlock Holmes. It just, I don't know. It was just something so glorious and glamorous about Scotland Yard as a kid. You know, I'm from the United States, so we heard a lot about Sherlock Holmes growing up. especially in the 70s and the 80s. So Sherlock Holmes is a fictional um, private detective created by British author Sir Arthur Conan Doyle, referring to himself as a uh, consolating detective. In the story, Holmes is known for his um, pro, uh, preference with observing um, forensic science and local resulting reasoning that borders on the fantastics when he employs when investigating cases from a wide range of clients, including Scotland Yard. First appeared in print in 1887, a student in Scarlet, the chapter um, probably became widespread with the first series of stories of short stories in the um, Strange magazines. The beginnings with the Scatters in Bohol in 1891. Additional tales appeared from them until 1927. Eventually totaling four novels and 56 short stories. Wow. All but one are set in vectoral or of Edward eras between about 1880s and 1914. Most are uh, narrated by the characters of Sherlock Holmes, friends, and by graphicer Dr. Watson, who usually completed um, accompany Holmes during his investigations and often shared quarters with him at the address of 221B Baker Street, London, where many of the stories began. Through, though not the first fictional detective, Sherlock Holmes is arguably the best known. The Guinness World Record listing him as the most portrayed movie character in history. Sherlock Holmes' um, popularities and fames are such that many have believed him to be not a fictional character but a real individual. Numerous literature and fan uh, societies have been founded that pretend to operate on this principle, widely considering a British cultural icon. The character and the stories have had a profound and lasting effect on mystery writings and popular cultures as a whole, with the original tales as well as thousands write by authors often then Cornet duly beginning adopting into the stage and radio plays, TVs, films, video games, and other media for over 100 years. Okay, what about Dr. Watson? Dr. Watson, known as John H. Watson, known as Dr. Watson, is a fictional character in the Sherlock Holmes stories by Sir Arthur Conan Doyle. Watson is Sherlock Holmes' friend, assistant, and sometimes um, flaked, flake mate, flatmate, and the first person narrator of all but four of the stories. He is described as the typical Victorian era gentleman, unlike the more eccentric Holmes. He is uh, assault although he can never match his friend's uh, deductive deductive skill deductive skills. Okay, I need to know this word. Astitude, astude, astude,
Astute.
astude. Astute have or showing an ability to accelerate, assess situations or people, and turn this to one's advantage.
Astute.
Astute. I got the word right, but I didn't know what it meant. Astute. That's what it means. So they're saying he's not as good as Sherlock Holmes. That's what they say. Okay, let's change up for a moment. I just wanted to practice reading on something that was interesting to me. I find that to be effective in trying to increase my reading ability. I'm not a very good reader, as you can see. And here, however, I'm about to practice with what's this? Electrical fundamentals. Alternate current, amperes, conductor, currency, direct current, electric, magnetic loads, power, um, rectifiers, resistance, transformer, volts, and voltage are some of the words that is going to be in this reading. So alternate current, an electrical current that changes direction on a current basis. Ampere, the units of measuring for current flow. The magnitude is determined by the number of electrons passing a point at a given time. Conductor, the mathematic, a material that rarely conducts electricity. Also, the wire that um, connects components in the electrical current C, in electricity, current C, the rate or volume at which electronic flow is a current measured in amperes. Direct current, DC, alternate current, AC. Direct current, DC, and electric currency that flows in one direction. A battery is a common source of DC voltage. Electric magnet, a coil of wire wrapped around a soft iron core. Core. When a current flows through the core, magnetism is created. Load, a device that convert electrical energy into another form of energy, heat, uh, mechanical motion, lights, etc. Motors are the most common significant loads in HVAC/R systems. Power, the amount of energy measured in watts consumed by an electrical load. Power equal voltage times current. Rectifier, a device that converts a AC voltage to DC voltage. Transformer, two or more currents of wires wrapped around a common core used to raise and lower voltage. Volt, the unit of measuring, the unit of measurements for voltage. Voltage, a measure in volts of the electrical portional current flow. Potential for current flow. We'll try it again. Voltage, a measure in volts on the electrical potential for currency flow, also known as electromotive force, EMF. A air conditioned heating and refrigerated system use electricity to obtain operating power for their components, fan, motors, and other load devices. Even a simple gas fire or oil fire furnace needs electricity to run the fan that circulates air through the building. In addition, electrical switches, devices, sensors, and indicators are used in the control cycle of the system. Some of these control systems are quite complex, containing thermostats as well as numerous switching devices. Many systems use microprocessor controls and some systems used in commercial buildings are managed from a central computer. Most of the problems on HVAC slash R technician technicians encounters on a service call involves the electrical systems. Therefore, it is important to understand electrical circuits and to be able to interpret complex circuit diagrams. Without the skill, diagnosing system problems would be pure guesswork. There are many sources of electricities. The majority of the electricities were used in generating at coal-fired power plants, like the ones shown in figures. Nuclear plants, nuclear power plants, are also a major source of electricity. Streams produced in a coal fire or nuclear power plant is used to divert huge turbine generators which produce electricity over sources of electricity, including turbine generated power by natural gas, as well as hydronical electronic power plants, where water flows over dams is used to drive turbines. The electrical power products by various energy suppliers travel through the long distances. Transmission lines. The voltage may be as high as 760 100 volts. High voltages are usually because they result in lower line losing over the long distances that the electricity must travel. Devices known as transformers are used to lower the voltage to more usual levels as it reaches electrical substations and eventually homes, offices, and factories. The voltage one receives at home is usually about 240 voltage at the wall outlets where we plug in small appliances such as TVs and toasters. The voltage is about 120 voltage. Large electrical loads such as electrical stoves, clothes dryers, water heaters, and air conditioning systems usually require the full 240 volts. Buildings and factories may receive anywhere from 204 voltage to 575 voltage. This depends on the amount of power the machine consumes. These they're consumed. Okay, let's fast forward a bit. So that's what we're about to read about. I think this is a great area. Um, continental, continent, continental, a continuous current path, the absence of um, community, community, continuity, continue, continue, continuity, and it indicates an open current. Inductive describes an operation when where a conductor becomes electrical charge from the beginning near another electrical charge body, or becomes magnetized by being within an existing magnet field. The process itself is called inductive insulators, a device or substance that inhibits the flow of currents through opposite of conductor. Ohms, the units of measure for electrical resistance. Relays, a magnetical operating device consisting of a core and one or more sets of contacts. Thermistor, a semiconductor device that charge resulting resistance with a charge in temperature. Watts, W, the unit of measure for power consumed by a load. An electrical current consists of four main elements to voltage source: a load device that uses the electronic product by the source, a control device that can be used to turn the current on or and off, and conductor to carry the current. When the current when the circuit is complete, an electrical current will flow in the circuit, causing the load device to perform work. The source produces a voltage that causes current to flow, while the load offers resistance to the current flow and consume power. Voltage, currency, resistance, and powers are the building block of electricity. An electrical current is caused by the movement of electrons from one point to another. Electrons are negatively charged particles that exist in all matter. When a difference is the number of electrons existing between 2 points, electrons flow from the negative point, the one with more electrons, to the positive point, the one with fewer electrons. The difference is electrical potential between 2 points is called voltage. Some voltage must be present for electrons to flow. Lighting is a good example of natural electron flow. A source cloud has a negative charge with respect to Earth. The lighting occurs when the difference is potential between the cloud and the Earth because so great becomes so great that the air between them conducts a current. In the common 12-volt car battery, a chemical reaction causes one of the polars to be negative with respect to the other. If a conductor is connected between the negative and the positive polars of the battery, electron flow from the negative pole to the positive pole. That's not the part I wanted to get into. This is the part I wanted to read about. In order to harness the potential energy of the battery, a resistant device such as a light bulb is connected between the two battery poles. Resistance is the potential that causes a material to resist or impede current flow. The resistance in a current creates an electrical load. When the switch closes, the moving electrons flow through the bulb, which converts the electrical energy into light. The bulb consumes the electrical energy in the process. The amount of energy consumed is known as power and is expressed in watts. A 60-watt light bulb is so named because it consumes 60 watts of power. Current is expressed in amperes, A, or amps. Voltage is expressed in volts, V, and resistance is expressed in ohms, OHM. The AC voltage HVAC/R technician works with usually ranges from 24 volts, 24 VAC to 600 VAC. The occasional DC voltage HVAC/R technician accounts will generally be low voltage aged in the 5 VDC to 15 VDC range. Occasionally, technicians may encounters a very high voltage currency, such as the initial current for a gas furnace, which may produce a 10,000 volt spark. Currency in HVAC are currently may be as low as a few microamps, millions of any amp. Current in the milliamps or MA, thousands of an amps ranges are more common. Some circuits, especially motorcycles, may carry very high current in the range of 100 amps or more. The important things to remember is that Even current is milliamps range can be hazardous under the right conditions. Um, Resistance are usually large values, um, expressed in thousands of ohms, kilo ohms, or K, or millions of ohms, uh, mega ohms, or M. In some cases, resistance values may be only a few ohms. For example, a thermistor heat sense, sensitive resistor use a temperature sensing device and as an aid in motor startups fall into this category. Voltage, current, resistance, and powers are close related. If you know any two of them, you can determine the other two. For example, if you know how much voltage is available and how much power the load consumes, you can figure out how much current the circuit will draw. For example, suppose you want to pull a 1,600 watt electric heater into a household circuit that is protected by a 15 amp circuit breaker. How do you determine if you can safely add the heater without overloading the circuit and tripping the current breaker? The wrong way would be to plug in the heater and see if the current breaker tripped. A better and less dangerous way is to calculate how much current is used drawn by each appliance in the current in the circuit, including the heater. This can be drawn. This can be done using the formula describing in the following. Ohm's law is a formula for calculating voltage, current, or resistance. The formula was derived by George Ohm, a German physicist, in 1827. The ver- the value in the formulas are expressed as E, I, and R, respectively. The letter E is used to represent voltage age based on Ohm's original complex of volume as electoral motive force E. Similar, the I for current is based on the intensity of electron flow. The three variations of Ohm's law, the pyramid provided an easy way to remember the formula. If you know two of the values, cover the unknown value with your finger to see how to solve the problem. For example, if the volume and resistance are known, covering the I shows that E is uh, divided by R to determine current I. For example, in a 120 volt currency containing a 60 ohm load, the current flow is 2A. The pyramid also shows the current I is multiplied by resistance R in order to determine the volume E. Note that that Ohm's law applies only to resistant currents because of the nature of alternating current containing motor relay coils and other inductive devices the same do not act the same as purely resistant loads. The subject is covered in depth um, in different mods and different readings. Most loads devices are rated by the power that consumes rather than the resistance that offers. The electrical heater described earlier has a ranging of 1,600 watts ohms. Ohm's laws will not help to determine how much current the heater will draw because two variables, resistance and currents, are missing in such instructions. The power formula must be used. Power P equals voltage E times current I. In the case I equals P divided by E would be used because current is the unknown value. The variations of the power formula as well as Ohm's variance in a 200 in a 120 volt currency. The 1,600 watt heater would draw 13.3 amps. 1,600 watts divided by 120 volts. The 15 amps current breaker would accommodate the heater, but just briefly if there are other appliances in the current that are operating at the same time as the heater. The current breaker, the currency breaker will probably trip. It would not be accessible to simple install a breaker with a higher current rate because the conductor may not be rated for the increased load. Overload electrical conductors are a frequent cause of fires, probably appliance over current protecting devices such as circuit breakers and fuses, preventing this from happening. Electric motors are often rated in equivalent horsepowers rather than watts. A large swimming pool pump, for example, may contain 2 horsepowers. Electrical motors. There is a simple conversion from horsepower to watts. 1 HP equals 76 watts. Therefore, a 2 HP motor would consume 1,492 watts in a 120 volt currency. It would draw more than 12 amps. The ability to perform this type of calculation is important because additional new loads to existing currents often need to be consumed by an HVACR technician. A basic electrical circuit is shown in figures 13 in this booklet. An electrical current is closed loop that contains a voltage source, a load, and conductor to carry current. It also contains a switch device to turn the current on and off. Circuit source current. Source current. No, series, right? Series current. A series current provides only one path for current flow. For that reason, the current is the same at any point in the current. The total resistance of the current is equal to the sum of the individual resistance. The 12-volt series current has two 30 ohm loads. The total resistance is therefore 60 ohms. The amount of currency flowing in the circuit is 0.2 amps, which is calculated as following: I equals E over R equals 12 volts over 60 ohms equals 0.2 amps. If there were 530 ohm loads, the total resistance would be 150 ohms. The current flow is the same through all the loads. The voltage measure across any load voltage drop depends on the resistance of the load. The sum of the voltage drops equal to the total voltage applied to the current in the case of 530 ohm loads. Each would drop 1/5 of the applied voltage. Currency containing loads in series are uncommon in HVACR work. In an important trait of series currents is that if the current is open at any point, no currents will flow. For example, if 5 light bulbs are connected to series at one of them below, all 5 light bulbs will go off because the continuous of the circuit has been broken. However, parallel. In a parallel circuit, each load is connected directly to the voltage source. Therefore, the voltage drop is the same throughout all loads because each load sees the entire applied voltage. The source sees the circuit as 2 or more individual circuits containing one load each. The parallel circuit is the source C, the third circuit, each containing a 30 ohm load. The current flow through any load is determined by the resistance of the load. Thus, the total current draws by the current is the sum of the individual current. The total resistance of the parallel circuit is calculated differently from that of the series circuit. In the parallel circuit, the total resistance is less than the smallest of the individual resistance. For example, each of the 30 amps draws 0.4 amps at 12 volts. Therefore, the total current is 1.2 amps, which is calculated as follows. I equals E slash R equals 12 voltage slash 30 ohms, 0.4 A per cycle times 3 cycles equals 1.2 amps. Now Ohm's law can be used again to calculate the total resistance. RT equals E slash I equals 12 volts slash 1.2 amps equals 10 ohms. This one was simple because all the resistance were the same value. The process is the same when the resistance are different, but the current calculation has to be done for each load. The individual currents are added to get the total current. Unlike series circuits, parallel circuits continues working even if one circuit opens. Household circuits were wired in parallel amongst all the HVAC load circuits you encounter will be parallel circuits, perhaps. Depends on who do it. Uh, Either of the following formulas can be used to convert parallel resistance to a single resistant value. The first one works only when they are two resistors in parallel, like I said. The second is used when they are three or more. Now, that's just some electrical understanding, right? Now let's go into something that in heating and cooling that you may not. Do I want to keep going? Hold on. This is measure watts. Let's see really quick. The testing meters are used to measure voltage, current, and resistance. The most common testing meters is the voltage ohms, million tester VOM. It also called the multimeter, shown below. Digital and analog multimeters. The meters combines a voltmeter, ohms meter, and multimeter in a single instrument. Voltage meter, ohms meters, and ammeters are available as separate, but such devices are usually used only in lab work. In field multimeters and clamps on ammeters either allows or as an accessory to the multimeter are the test instruments commonly used for voltage, current, and resistance measurements. A an analog meter is so called because the pointer moves in the pro, pro proportions to the volume being measured. The persons using the meters must then interpret the scale to determine the measured volume. A digital meter displays the result numerically in the screen. The range of the digital meter can usually be selected for the results for the desired level of precision. Nope, I didn't want to read that. Yeah, I think this was interesting to me. Current digital, no, current diagrams, often known as wiring diagrams or wiring schematics, use symbols to represent the electrical components and connections. In this series, you will learn about electrical components and how they are shown in wire schematics. Electrical components generally um, falls into category load devices and control devices. Some devices, relays, for example, contain both an energy consuming element load and a control element switch contact. The switch contacts are threaded as treated as a control device. Since that is the functioning that performs the symbol commonly used on wiring schematics are shown. Okay, motors converting electrical energy into machine energy in HVAC system. Motors are used primarily to drive compressors and fans. Electrical motors are the most common load founded in HVAC systems. Cooling systems use motors to turn the condensers and evaporator fans and to run the compressors. Furnaces use them to turn their inductor draft fans and blow fans. Of motors, of some of the ways that motors are depicted in schematics, wiring diagrams, because it is likely that the three or more motors will appear on a typical HVACR current diagram. A letter code such as IFM, indoor fan motor, is used to identify the functions of a particular motor. The same is applied to another component that appears on circuit diagrams in most common systems. The compressor motor is by far the largest single electrical load in a residential system. The indoor blower motor and outdoor conductor fan motor may draw only a few amps of current, while the compressor may consume 7 to 10 times more, 10 times the amount. Electrical heaters are also called resisting heaters because they are made of high resistant materials that consume a large amount of electricity, which they convert into heat. They are somewhat like the burners of an electrical stove. The diagram symbols for an electrical heater is usually the same as for the resistance. It is common when replacing a furnace with a heat pump to find that it is necessary to apply the electrical service. This can represent a signal significant cost to the building's owners. The sales engineers who specify the systems must take such factors into account when pricing the job. A heat pump system can also use a false fuel furnace as supplemented energy heat. This um, often help avoid the additional cost of electrical upgrades when the furnace is used to supply the heat pumps. Only one or two units can operate at one time. Um, supplemental electrical heat though can operate right along with the heat pumps, allowing it to continue anytime heat is needed. There are many types of um, control devices. These primary functions is to turn loads on and off. Many control devices also control the uh, actions of other controls. Anyone working on HVAC will encounter these devices on a daily basis, both in the equipment and on the circuit diagram. Although some control devices don't operate at the same volume as the load, most control systems operate at a reduced voltage, such as 24 volts. All right, that's just what I wanted to read really quick and compare it the my reading today with the understanding of the system. Where is it? Let's try right here. Maybe this is a good spot to start at. Maybe heat pumps, operating principles, coefficient of performing COP for heating pumps. It is the ratio of the heat producing in relations to the energy used. It is calculated by the use of the following equation: COP equals BTUH divided by watts times 3.413, or COP equals BTUH divided by K watts equals 3,413. A heating pump, function by extracting heat from outdoor air, a water source, or even a ground source. That heat is then transferred indoors when it is released to heat the structure. The understanding how an air source heat pump works, it is necessary to understand that regardless of how cold it is outdoors, there is still some heat in the air. Water and ground source typically offers more consistent supply of heat. However, since air sources models are the most popular and uh, ver- ver- versatile, the forces of this discussion will remain in the unit as long as the temperature is above absolute zero minus 460 degree Fahrenheit, which is 0 degrees Kelvin, K on the Kelvin. There is some amounts of heat contained in the air of course, at warmer temperatures. This is more heat available. As air temperature drops, there is loss. There is lost heat available for the heat pump to extract. Most heat pumps beginning losing effectively quickly when the outdoor temperature falls below 35 degrees Fahrenheit. Okay, that was understanding, but that's not what I was looking for. Split systems. A split system is one that has two separate units. The outdoor air-to-air heat pump unit contains the compressor, reversing valves, outdoor coils and fans, and controls in the heat pump system. The unit would also contains one of the metering devices, the outdoor units, which is also known as the air handler or fan coil unit, containing the outdoor fan blower. The meter devices and the outdoor coil electrical heaters, if installed, would also be located in this unit of mounted on the supply air outlet. A variation of the split system is the triple split system, in which the outdoor unit contains only the outdoor coil, outdoor fan, and a metering device. The compressor, reversing volume, and the controls are located in a separate unit that is installed indoors. This arrangement is very effective and is much easier to service in bad weather. Despite its advantages, the triple split system was not widely used. Another type of split system is the ductless supply system, which is designed to serve a single room or area. The outdoor, the indoor fan coils, the units can be mounted on a wall or fit into a drop ceiling. Some units installed in a drop ceiling can be connected to a short run of ducts to service more than one room. The floor mounts handlers are also available. The outdoor units is typically normal and rectangle and looks like a suitcase, making them ideal for installing in tiny spaces installed of use using a traditional room thermostat. For typical control, ductless splits are often controlled with a wireless remote, similar to the remote used to control a television. Whoa, that sounds sweet, don't it? Especially when you can just say, turn the heat to 60. Voice command. That's not what I was looking for right there, though. I was looking for some practice reading on explaining, because it's a lot. I like the electrical and the heating system are so much similar. Uh, Maybe this I'll find it in this book. Practice for right now on YouTube live. Okay, that's not the book neither. I thought I seen something. Maybe it's in book one. Maybe I just passed it in such a rush because the battery. Let's see it right here. I think I might. Yeah. This is what I looked at. Perhaps. I believe this can explain it. You may go a little bit more in depth to what I wanted to practice reading. Oh boy, this is a nice little. Oh, oh boy. Let's try this. I might not finish this. Let's see, compressors. Anybody want to know anything about compressors? Anybody want to? Compressors. The compressor is the keystone of refrigeration systems. It creates the pressure difference that causes refrigeration to flow. Difference in process cause the flow of fluid. Direct of flow is always from the high pressure to the low pressure. Much of the heat moves from a hotter temperature to a lower temperature. This results in a liquid and gas can be made to move by adjusting or changing the pressure around them. In refrigeration, a compressor is used to create the pressure difference that causes the refrigeration evaporation to flow in a system. Note that liquid cannot be compressed and substantial amounts of liquid flowing through a compressor can damage or destroy it. As compressors ingest refrigeration vapors at a low pressure and compressor it to be a higher compressor, additional heat is generated. The refrigeration vapors also absorb some of the heat from the compressor motor in models where the motor is an integrator part of the compressor structure. Compressors are usually divided by an electric motor. Compressors are usually divided by an electric motor. Very large compressors can be divided by combustion engines or steam turbines, but this is rare. Compressors are divided into three groups based on the way they are joined to their motors or engines. Open drive compressors. This type of compressors is physically separated from its motor. The drive shafts of the compressor extends outside the case. A mechanical seal is used with the uh, rotating shaft to prevent leaking of the refrigeration. The compressor motor can turn. The compressor use propellers and belts. This is referred to as the belt drive. The motor can also be connected directly to the drive shaft for a direct drive arrangement. Belt drives arrangements allow the motor to run at one speed while the compressor can be ran at another. The uh, proper combinations of propellers produce the desired speed of the compressor. Direct drive units turn the compressor to potential compressors at uh, precious procedurally the same per personally personally um what's this word? One second. I'm stuck on this word. Per I always get stuck on this word. Pers processively the same speed as the motor. Um, it means accurate. I just can't say the word unless I say accurate. Precisely, preciously, preciously, no. Okay, let's see if I can guess the word. Get the word. Technology. So I'm going to go Google when I find it when it pop up on my phone. I need Google. So there we go. My phone loaded up. And I need dictionary.com. So go to dictionary.com when I spell a word. Once I get to dictionary.com, I know what it means. I just can't say it.
Precisely.
Precisely. Couldn't say it. I know when I get to precisely, that means I gotta stop because I know what the word is, and it means pay attention precisely. So it's like a mental block I got. Whenever I see the word precisely, it's like, gotta pay attention. Precise speed, precise is what I was trying. Precisely, precisely, precisely the same as the motor. It can't be up or down. It got to be on the money. Open drive compressors can be open for service and repair. Hermetic wired seal compressor. This is we talking about money now. The compressors and motors share a common drive shaft. There are seals in a wired seal enclosure of or shell. The hermetic compressors are more complex, less noise, and require less management than open drive compressors because they have no belt or scoopling to break or wire or wear out because they are sealed. Each unit, each entire unit must be replaced when it fails. However, open drive compressors are available in much larger uh, capacities than hermetic models. Hermetic compressors also cannot be serviced in field when um, entire problems occur. The compressor must be replaced in its entity. The failure compressor is scrapped or returned to the manufacturer for evaluation or warranty credit. Hermetic models with capacities below 10 tons are mostly uh, popular, but the use of the compressors is higher capacities in increasing the uh, rapid duties, um, rapidly rapidly duties to improve the manufacturing techniques and the demands for large compressors as a low initial cost. Semi-hermetic servable hermetic compressors, similar to the hermetic compressors. The compressors and motors share the same housing and drive shafts are different connected. These compressors offer some com, com, compromise between open drives and hermetic models. They can be open for service and replace of the intake and exhaust uh, valves and some other components by removing the heads and of the bottom up and the end of the housing. However, if the motor fails, the entire compressor is replaced. Failure results to the crankshaft, pistons, and piston rods usually result in complete replacement as well. These compressors are rarely destroyed when they fail. Instead, they are disassembled and remanufactured or rebuilt at shops designed for these purposes. Money, honey. And that's why I'm gonna stop. Didn't even go into where I don't feel like doing it right now. Actually, I feel like it, but nobody want to hear this. I was just practicing reading, so I talk.